In this video, we're going to spend time learning how to graph a logarithmic equation. So let's go back and recall that if we have the graph or the equation y equals log base 2 of x, that's actually the same thing in exponential form of x equals 2 to the y. So I'm going to go back and I am going to take the equation x equals 2 to the y, and I'm going to pick values of y to substitute in and get values of x. So if I put in negative 2, I get 2 to the negative 2. But 2 to the negative 2 is 1 over 2 squared, which would be 4. If I put in 2 to the negative 1, I get 1 over 2 to the 1. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. And 2 to the 3 is 8. So now if we plot those points, we have 1/4 negative 2. So that's going to put me right here close to the y-axis. I have 1/2 negative 1, 1 0, 2 1, 4 2, and then 8 3. So we can see that our graph is increasing, but it's doing it very slowly. But as we get closer and closer to the y-axis, our graph gets steeper. Now I want to go back and compare that to the graph of y equals 2 to the x, which we graphed previously. Well, remember, those gave me, if I put in x is 0, 2 to the 0 would be 1. If I put in x is 1, I get 2. If I put in x is 2, I get 4. X is 3, I get 8. Then I'd have negative 1 would give me a half, negative 2 would give me a fourth, and so my graph looked like this. And if you recall when we talked about functions that were inverses, which we know that these two are inverses, we said that they were always symmetric about the line y equals x. So if I kind of plot in the line y equals x, I'll see that, let's kind of dash that line now, that's the line of symmetry. So if you recall with exponential graphs, we said that they always went through the point 0, 1, then we could shift them. Notice that with a logarithmic graph, it goes through the point 1, 0, and then exponentials start flat and get real steep, whereas logarithms start real steep and then they flatten out. They're exactly the opposite or the inverse of an exponential. So let's go back now and sketch the graph of y equals log base 5 of x. So remember that we can rewrite this as 5 to the y equals x. And I can pick values for y to substitute in. So if I put in negative 2, 5 to the negative 2 would be 1 over 5 squared, which would be 1/25. 5 to the negative 1 would be 1 over 5. 5 to the 0 would be 1. 5 to the 1 would be 5. 5 to the 2 is 25. And 5 to the 3 is 125. So now, marking along our x-axis and looking at our scale, we need to go from, let's say, 0 to 125. So let's count off by tens. So that'll be 50. That'll be 100. And then we'll just kind of expand this out and make that 150. All right. And let's actually start graphing these last few points so we'll have a little better idea of what the graph looks like. So we'll start here at when x is 125, which would put us right around here. Y would be up here at 3. When x is 25, which would be right here in the middle, y would be 2. When x is 5, which would be here between the origin and the first grid mark, y would be 1. And then when x is 1, y is 0, so that's just barely past the axis. And then we can see that this should be getting closer and closer to our y-axis. So our graph should be coming up like this. So keep in mind that because this is the exact opposite of y equals 5 to the x, which is exponential, our graph should start steep and then flatten out as it goes out. Now we're going to take a minute and we're going to graph the graph or sketch the graph of y equals natural log of x. So again, rewriting this into an exponential form, remember that natural log has that little base e. So this means e to the y is equal to x. So if we pick these values for y, we can get our x values. So if we'll start with 0 first because that's the easiest one. E to the 0 would be 1. E to the 1 would be e, which we know is 2.7. E to the second, you can use your calculator and get that e squared is 7.4. We'll just round to the 10th. E cubed is 20.1. E to the negative 1 is 0.4, and e to the negative 2 is 0.1. So using those points to sketch, we will go ahead and count this off. Since we've got a little more room, we only need to go from 0 to 20. We'll count these off by 2's. So we'll call this 10 and this 20. So 0.1 would be right up against the y-axis, negative 2. 0.4, negative 1. 1, 0. It's a little bit closer than what I've got sketched there. Let's try that again. 1 would be right here in the middle. All right, and move that back a little bit. And then 2.7, which is going to be almost at 3, would be at 1. 7.4 would be at 2. And 20.1, so we're just out past 20, is up here at 3. And notice that that does look like our other exponentials. We start flat, or steep, I mean. We flatten out as we go. Kind of pretend we hit that dot. And notice that we did pass through the 0.10. All right, so the last thing we're going to do is we're going to take just a minute to do some rough sketches like we did when we graphed exponential functions. And remember our translations on how we move things left, right, up, down. So the first thing we're going to graph is log base 2 of x plus 3. So we know this is a logarithm graph. The plus 3 at the end, since it's not in parentheses, because we can kind of visualize that's the problem, means that we're going to shift everything up 3. So normally we would pass through, and I'm just going to draw a little dot here, the point at 1, 0, but that dot's going to move up 3. So now we're at 1, 3. And then our exponential graphs are steep and then flatten out. So I'd expect the graph to look something like that. Log base 5 of x minus 4. Since the minus 4 is inside the parentheses, that moves us to the right. So again, we would normally start at 1, 0, but we're going to move to the right 4. So that's going to put me at 5, 0. And we're going to start steep and get flat. Now we still have that asymptote that's 1 unit from where we touch the x-axis. So notice that I don't go past 4. And then the last one, log base 5 of x plus 2 minus 1. So we have two translations here. The plus 2 is going to move me to the left. Remember that inside the parentheses is left and right. And then the minus 1 at the end is going to move me down 1. So normally I would have gone through 1, 0, but now we've moved 2 to the left, which puts me at negative 1, and down 1, which puts me at negative 1, negative 1. and then we start flat or steep and get flat. And again, since my dot is located over -1, then I don't want my graph to go past -2. That would be my asymptote.